Hello students and welcome to the next module of Concept of Beats. Students, in this particular module, we'll be learning how our beats actually form. Based on the principle of superposition of waves, let us go ahead and learn the formation of beats. Students, first we have to consider two waves having the same amplitude. Can you see the above two waves have exactly the same amplitude and slightly different frequencies? If you see them carefully, there is not much change that you can actually see by the naked eye. But over here, I am going to help you. Students, if you carefully consider both the waves, one in blue and one in red, if I am marking the completion of one wavelength, I can clearly see that there is a slight difference. So in a given time, both the waves are completing unequal amounts, and that is why I will say that their frequencies are different. So over here, students, what do we see? After these two waves superimpose on each other, what happens is this is the resultant pattern that we get. If we analyze this particular resultant pattern in depth, what do we see? First of all, in the red colored box shown, can you see that the crest is coinciding with the crest? So, as the crest is coinciding with the crest, constructive interference takes place exactly this way. That means the resultant amplitude is going to be double the actual amplitude. Let us go ahead. Further, if we analyze this second red colored box that just came on the screen, can you see that a crest is coinciding with a trough? So very clearly, the resultant pattern will show no intensity or minimum intensity, and that is why, students, I say that destructive interference is going to take place. Now students, the resultant pattern looks exactly like this. That is, if two waves are continuously getting emitted having same amplitude and slightly different frequencies. Students, remember, the frequencies have to be slightly different in order to get beats. If there is a large difference in the frequencies of the two waves, you will not hear any beats. So let us go ahead further, students. If we go ahead further, we see this as a snapshot of nothing but our resultant wave pattern. Now students, we are talking about sound waves. When compression is coinciding with a compression or rarefaction coincides with a rarefaction, we get constructive interference, and thereby, students, we get loud sound. Further, students, if we consider the next case, say compression is coinciding with a rarefaction. Also, a rarefaction is getting coincided with a compression. What happens? Destructive interference. Once again, students, in this particular case, we have soft sound. That means we have alternation of loud sound and soft sound. But students, this loud sound and soft sound has got names as well. One is called waxing and the other one, students, is called waning. So every time, students, you are going to have loud sound, we will call it waxing. And every time we are going to have soft sound, we are going to have waning. So students, let us go ahead and see a few definitions for beats. The first definition: the alternate periodic waxing and waning produced due to the interference of two sound waves of equal amplitude but slightly different frequency is called beats. Next definition, students, is for beat period. The time interval. Beat period, that means obviously it has to be a time. The time interval between two successive waxings, that is loud sound, or wannings, that is soft sound, is called a beat period. Further, students, beat frequency, it is nothing but the number of waxings or the number of wannings which occur per unit time is called beat frequency. These three definitions, students, are very important. I'll see you for the next module. Thank you.